Right, we've got a transformations question here. Draw the image of triangle A after reflection in the line y equals -1. That's just basically saying transform A in the line y equals -1. So let's get this line up. First of all, this is where y is -1, but the line is actually all the way along. So to remember it, just remember that it's the one that goes through the y-axis and at -1. Sometimes people want to make that one y equals -1. That's x. Well, that one's x equals -1 going vertically. Okay, really important to know those two types of lines. Right, let's do some reflecting. So if we take this bottom right point here, then we have to go at right angles to the reflection line. We'll go 1, 2, and then another 1, 2. So we come there. Bottom left, 1, 2, 1, 2. Top left, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there we go. There's our triangle. We just need to join the points up. Nice one. Done. Okay, describe fully the single transformation that maps A onto B. Well, the first thing I note is that it's got a bit smaller, so it's going to be an enlargement. And the second thing is that how much smaller has it got? Well, it was 2 in length, it's now 1, and it was 3, and now it's 1.5. So to go from here to here, I've divided by 2, or equivalently, I've multiplied by 1/2, and that's what it's looking for. Enlargement by scale factor 1/2. Or words to that effect. Just the last thing is the centre of enlargement, because this triangle up here is also an enlargement by a scale factor 1/2. So why has it ended up here? Well, let's just take a quick recap. So if we're doing an enlargement and we're given the centre of enlargement, what you do is you draw ray lines, and then you sort of, if I was doing a scale factor 2, instead of going that distance, I'd go twice that distance, or equivalently, instead of counting along the squares, I'd count along twice as many squares. And I'd have to do this really carefully. That's not right. Yes, it is. That's okay. And it might look a bit like this, and that would be my biggest square. Actually, not too bad. The point is that if I have a centre of enlargement and a shape, and I do a scale factor of say 2 or 3, the shape goes beyond and gets bigger over here. However, if I started out with this shape and the scale factor was 1/2, then I'd end up with this shape here, because I'd go half the distance. And what I'm trying to say is that the centre of enlargement is between the smaller shape and the bigger shape. So it's going to be up here somewhere. It's going to be between the smaller shape and the bigger shape. You didn't necessarily have to know this in detail, but I think it's going to tell me where to draw my ray lines. I'm not going to be drawing my ray lines down here. Okay, they wouldn't join up then. I need to join them up this way. Okay, so I'm drawing through the points, the corresponding points, and continuing, and then I can see that there is a point where they meet. Now, I don't think I've been quite as accurate as I should have, because you're probably thinking it's off the coordinate grid, but it should be on the coordinate grid. So let's just be a bit more careful. Okay, that's a bit better. You can see now, hopefully, that it is this coordinate here. It is 5, 7. So enlargement by scale factor 1/2 with centre of enlargement 5, 7. Okay, yeah, that's quite a tough enlargements question, I think. It really tests whether you understand it well. You've got to be able to deal with the fact that it's a scale factor 1/2 that we have done. All right, last part of the question. A rotation of 180 degrees around 0, 0 has the same effect as an enlargement by scale factor something with centre of enlargement something. All right, it doesn't say what shape to do it about, because it's saying it's true for any shape, but I think a good idea is to just try it out on a shape if you're not sure what's going on, and I think that's a good idea. So let's do it for A. what you'll do is you'll do a rotation of 180 degrees around 0, 0. So get some tracing paper, draw over the triangle, add a little arrow if you like, because that'll help you see a bit more clearly that you're doing 180 degrees. And then, you know what, adding the arrows messed up on my screen, so you should add the arrow, but I'm just going to do it without. Okay, that's going to be 90 degrees, that's going to be 180 degrees. So there we go, there's my transformation of 180 degrees around 0, 0. You put your pencil on that point there. Sorry, I did that quite quickly. Okay, what enlargement is that? Well, the first thing is that it's not got any bigger, it's just moved. So it's got to be an enlargement, but it can't be 1 because 1 would keep it the same. So this is actually a negative scale factor. When you have a negative scale factor, you go through the centre of enlargement, and actually I can see it's going to be 0, 0, because if I was to do this this one that I've just put in, I would take every point and I would take it through the centre of enlargement, which is different from when you've got a positive scale factor. So I'd go one diagonally and then I'd go another one diagonally, and you can see that matches up. With the top left hand corner, I'm going to go down here like so, and I'm going to carry on. I can see it ends up in the right place, and the same is true for the bottom right. I'm going to go 3 along, 1 down, and then carry on. So that works. So that's just something to be aware of. Negative, I think that's, again, you know, there's only question 5 in the paper, but there's some really testing questions on transformations. Hopefully you're happy with it. Here we go.